Hello, good morning.
Good morning, sir.
Good morning to all of you. Is the screen appearing?
Yes, sir.
Is it audio audible?
Yes, sir.
Okay. So we will start the class now. So we are ended the class day after yesterday at the problem solved. I have given two problems for your homework. Example 4 and example 5. Have you completed? Have you completed?
Yes, sir.
Okay. So the next topic
Yes, sir.
is the two
Yes, sir.
The next topic is two-stage RC coupled amplifier circuit. Is the most important topic, mostly asked in exam papers. It is repeated question. So kindly concentrate. So this in this concept we have now it okay.
Yes, sir.
My voice is clear.
Yes, sir.
Yes, sir.
Whether screen is appearing.
Yes, sir.
Okay. So in the two-stage RC coupled amplifier, we have two stages of CE amplifiers, common emitter amplifiers connected in cascade with the capacitor in between. So through resistors and a capacitor in between. This is the coupling capacitor. You can call it as a coupling capacitor. So this coupling capacitor used to couple the first stage of C amplifier to the next stage of C amplifier. So if the output of the first stage is given to the second stage through the coupling capacitor. So that is the reason it is called a RC coupled two-stage amplifier. So why? Because you have a two stages, stage 1 and stage 2. The input signal, which is a AC signal, is connected to the stage 1 and the output is taken at the load resistor here. Okay. So if you see the circuit details, it is a two-stage RC coupled amplifier and it consists of a two series-stage transistor amplifiers using CE configurations. And the first stage is connected to the second stage through the coupling capacitor CC and a resistor RC. What is RC? RC is the, what is that? It is the collector resistance. Therefore, this amplifier is known as a RC coupled amplifier. So the resistances R1, R2 and RE form the biasing and stabilization network. So what are the resistors here? R1, R2 and RE. These three resistors and CE coupling, this CE is emitter or bypass capacitor, which will forms the voltage divider biasing network. Okay, so mostly used biasing network is voltage divider bias for the CE configuration. So the biasing is provided by the this three resistors R1, R2, RE as well as the bypass capacitor CE, or the CE capacitor you can also call as a emitter capacitor. Okay. So and the emitter bypass capacitor CE offers low reactance pass to the amplified AC signal. So it will provide the low reactance, means it is a high voltage gain. reactance is low, that is resistance is low, means current flow is more, that means gain is also increases. If you are using a bypass capacitor CE, if you are not using bypass capacitor CE, the voltage gain will be drops, it will be reduces. That is the reason you have to increase the voltage gain. You should add a CE bypass. You have to bypass capacitor or CE emitter capacitor. You have to connect through the RE, through across the RE. Okay. So if you see the working of this, what is the working means? Simple to understood here. So what is the first stage it is doing? Any amplifier, what is the purpose of the any amplifier? Whatever the input signal, it should be amplified. You have to send the input signal. So the amplified signal you should be given to the second stage. So that is also, it will also amplify the signal and then you will get the RF. That means you are multiplying or you are enhancing the voltage gain more and more by increasing the number of stages. That is the reason you are going for a multi-stage amplifiers or multiple amplifier stages. So, if you've seen in the working condition of this CE configuration of your two-stage amplifier, when a AC signal is given to the base of the first stage transistor, the amplified signal will be developed across its collector resistance RC1 of first stage. Okay, is it clear? Very simple to understand. What is the purpose of the amplifier? It is used to amplify the signal. So, whatever the signal, AC signal you are given at the base of the first stage, it will be amplified and then it is given to the RC1. The output will be collected at the RC1 of the first stage. And then the amplified signal developed across RC1 is given to the base of the next stage through coupling capacitor CC. Okay. So we already discussed that. What is that? What is the configuration you are given here is a RC network, RC configuration. So in the RC configuration, resistors as well as the coupling capacitor CC, and the coupling capacitor will couple the first stage output to the second stage. Okay. So what is this is the second stage. You have to connect it through this CC coupling capacitor. Then the resistance R1, R2 and RE will provide the biasing, and then it allows only AC signal but blocks DC. Thus the DC biasing of the next stage is not disturbed. That is the why coupling capacitor CC also called blocking capacitor. Okay, what is the capacitor general criteria, just general characteristic of a capacitor? It will allow AC, it will blocks the DC, correct or not?
DC.
It will
Yes,
block
sir.
the DC and it will allow the AC. So
AC.
that is that is the reason whatever your signal you are given is the AC signal. If anything added, that is what is the anything added means, that is noise. If the noise is added, then what will happen? This coupling capacitor will blocks the DC signal. Okay. So generally, what will happen if you are even the given the AC signal also, some DC is produced in the circuit due to this VCC. Due to VCC, you are you are connected to this network, which is a power supply, which is a DC signal. So even though your AC signal is input, the VCC is also added some DC to the circuit. So that DC is now you can call as a noise. So that noise plus AC signal, that means AC plus DC, it is given to the next stage. But due to this coupling capacitor, what will happen? The coupling capacitor will blocks the DC. Only it will allows the AC to the next stage. So that is the reason you are placing a coupling capacitor in between the two stages. So that is the reason the CC you can also call as a blocking capacitor. The CC you can also coupling capacitor as well as blocking capacitor, because it will block the DC signal, because it will reduces the noise, it will reduce the DC signal, it will blocks the DC signal. That is the reason it is a blocking capacitor. Okay, so the next stage, second stage, further amplified the signal and appears across the RC2 of second stage. In this phase, the cascade stages amplify the signal and overall gains considerably increases. Okay, is it clear? So overall gain is improved. Because why? You are just AC signal is given to the first stage, it will amplifies and given at the output of RC1, and through this output signal is now connected to your second stage through coupling capacitors. Then in second stage also it will amplifies furthermore, and it will given at the output signal V0 at low resistance. Okay, so here like this it will amplify the original signal or input signal or AC signal. Okay, so what is the purpose, main purpose of this capacitor CC is it will couples the first stage to the second stage in the first one. Second purpose is to blocks the DC signal. Why DC is coming into picture? Because the VCC is the power supply which is adds the DC to the circuit. So that is the reason it will blocks the DC as well. So that is the reason the CC is also you can call as a blocking capacitor. Okay, so like this the signal which is connected at the input side will be amplified through this second stage, multiple stages like this. At the output side you will get the output voltage which is amplified version of the input signal. Okay, so what are the advantages if you seen? So it is not expensive. Why? Because only resistors and capacitors are present, no bulky elements are present. That is the reason it is a small and light and inexpensive. So this is the first advantage of the RC coupled two-stage RC coupled amplifier. And the second advantage is its overall amplification is higher than that of the other couplings. So if you see in the next two stages, we also seen a number of this type of configurations. In that comparing that configuration, transformer coupled or frequency response wise also it is good. Okay, so overall amplification is good as well as frequency response also excellent in the case of compared to other configurations. And the other advantage is minimum possible non-linear distortion also present in the circuit. If you see in the transformer coupled amplifier, it has a more distortion, whereas in the RC coupled amplifier, this type of stages, the distortion is very less. Okay, because if you add the transformers like bulky components like transformers or inductors, the non-linearity will increases. Non-linearity means non-linear distortion will increase, whereas in this RC coupled amplifiers, the distortion will be very less because of only R and C components you are using. Okay, so are you understanding here? So what is the primary advantage of this two-stage RC coupled amplifier? It is not bulky, its size is very less, very small, light and inexpensive, and overall amplification is higher than that of the other coupling networks, and its frequency response is excellent, and it has a minimum non-linear distortion compared to the transformer coupling amplifiers. Okay, so major disadvantage, what is the major disadvantage is pure impedance matching. So impedance matching is missing here. So what is the meaning of impedance matching? Means higher input impedance, lower output impedance, then you can call as a impedance matching. That means you can couple maximum amount of output to the load, then you can call as a impedance matching is excellent. If you are not able to couple more output to the load, then you can call as a poor impedance matching. So here you will available poor impedance matching, whereas transformer coupled amplifiers impedance matching is higher because you are using a transformer at the output side. So that is the reason here major disadvantage is poor impedance matching, and the power gain as well as voltage gain also very less compared to the transformer coupled amplifier network. Okay, and direct coupled amplifiers. So this is the major disadvantage of the RC coupled two-stage RC coupled amplifier circuits. Is it clear, all of you?
Yes, sir.
Yes, sir.
Listening or sleeping? Okay. See here, if you seen what is the purpose of the coupling capacitors? Tell me one.
It couples one stage to another stage.
The
First
stage,
stage
sir.
First
to
purpose,
second
second
stage.
purpose. What is the second purpose?
It blocks the DC,
Block
sir.
the DC.
Very good. Why DC is coming to
Allows
here?
AC. Allows
From
the AC
VCC,
signal.
sir.
From
Why
VCC,
DC
sir.
is coming?
From V,
Why DC is
sir,
coming to the circuit?
from VCC, sir.
Very good. The VCC is a DC signal which is adds the circuit some signal. Actually, you want to only AC signal to be amplified. You doesn't want to amplify the DC signal. That is the reason the unwanted signal which is you can call as a noise. So here DC is the noise. So in order to eliminate this purpose of DC, you have to add the one coupling capacitor in between. So that is the reason you can call as a blocking capacitors. So what is the voltage gain and power gain of a RC coupled amplifier, whether is a less or more compared to other networks?
Less.
Less, sir.
Less. Why?
No.
Why? What is the reason? Because of poor impedance matching. So what is a poor impedance matching? What is the meaning of poor impedance matching? It will not
Load is the
produce the
minimum.
maximum output voltage to the load. If you want to couple more energy to the output load, you have to obey the maximum transfer theorem. Where the circuit which is applied to maximum power transfer theorem is impedance matching network. So the impedance matching network is example is transformer. The transformer, if you use at the output side, the maximum energy will transfer to the load. Here we are not using any transformer network. That is the reason it is providing a less impedance matching. That is the reason less output you are getting at the output side, okay, or to the load. Okay, so this is the AC. You want to amplify AC signal or DC signal here?
AC signal, sir.
It will only AC signal you want to amplify. Okay, so what is the disadvantage? Major disadvantage?
Poor impedance
Poor
matching.
impedance matching.
What is
Low
the
voltage and power.
advantage?
Voltage and power. Low voltage and power.
What is the major advantage?
It is required.
It is small, light, and inexpensive.
Inexpensive. It is a low cost, very less cost because of the only R&C components. Very small resistors, small capacitors will be required to construct this circuit. So very small values, very less value, very low cost value of R&C. It is in the order of only paisa. Okay, 1 rupee or 2 rupees resistors, capacitors are used to construct a overall network. That is the reason it is an inexpensive, very less cost amplifier network. Okay, so next, what is the frequency response of the circuit? So what is the frequency response circuit? If you see the frequency response, what is the definition of frequency response? Define. What is the frequency response?
The curve drawn between voltage gain and signal frequencies, sir.
Good. Frequency versus gain. So it is a curve drawn or characteristics drawn between a frequency and a gain. So if you see in this characteristics or curve, it is like inverted tub. So tub, if you know the tub, it will inverted. Okay. So it is looking like inverted tub. Okay. Tub, bathing tub. If you see in bath tub, how it is there? It is inverted. Same like this tub is there. It is inverted. So it is inverting tub. The characteristics is inverted tub. So that means what? First it will increases. So in the low frequencies it will increases. In the mid frequencies it is maintain constant gain, and higher frequencies again it will decrease. Is it clear? So if you see the frequencies in RC coupled amplifier, gain remains constant at the mid frequency range. How much range of frequencies? 50 Hz to 20 kHz, and falls at low frequencies. That means less than 50 Hz and higher frequencies greater than 20 kHz. Is it clear? The frequency response or gain will be fall below 50 Hz and above 20 kHz, and in between 50 Hz to 20 kHz it will maintain constant gain. Here the mid range of frequencies only you should operate this two-stage RC coupled amplifier. Okay, because the gain is constant. The gain will fall in the below 50 hertz, above 20 kilohertz will not work. The RC coupled amplifier or frequency response you should not use here, because the gain is reduces. Whereas this frequency ranges, the gain should be constant. That is the reason you should operate in this region only. Why? Because gain is stable, or the circuit is stable. If you are not stable, the output is also not stable. It will fluctuate. So that is the reason you should maintain the frequency response constant always. That is the reason the stability of the gain will be constant, and the RC coupled amplifier will be applied in this region. That means 50 kilohertz to 20 kilohertz only. Okay. So what is the reason? What is the reason the gain will fall in the below 50 hertz and above 20 kilohertz? So in the low frequency range, what will happen? What are the capacitive reactances? Xc. So what is the capacitive reactance? Is inversely proportional to the frequency. Correct or not? Xc is inversely proportional to frequency. Why? Xc equal to 1 by c omega. Correct or not? Omega equal to 2 pi f. So C is inversely proportional to F. That means frequency increases, capacitive reactance will decrease. So frequency decreases, capacitive reactance will increase, like this. Okay. So it is inversely proportional. So in the low frequencies, what will happen? The frequencies are less. Correct or not? The low frequencies, it is less than 50 hertz. So reactance of the capacitor CC quite large. Correct or not? CC is more, so reactance is more. That means the resistance of the offered by the capacitor is more. Then current flowing is less or more. The resistance offered by the CC coupling capacitor is more. What is the current? Will increase, decrease? More
Decrease.
it will decrease. Current will decrease. Voltage also decrease. So voltage gain also decrease. Is it clear or not? Very simple to
Yes,
understand.
sir.
You know the formula Xc. What is the formula for Xc? Xc equal to 1 by c omega. Omega equal to 2 pi f. F is more. F is more means Xc is less. You know, in the low frequency range means F is less. Correct or not? Less than 50 Hz. F is less.
Sir.
Xc is more. Xc is more means capacitive reactance is more. That is, the resistance offered by the capacitor is more. So what will happen to the current flowing? The current flowing in the circuit is less. So voltage also less. So that what will happen? Voltage gain also reduces in the low frequency range. So that is the reason the low frequency range, the gain will fall. So they will ask in the interviews, why gain will fall in the case of low frequency range less than 50 Hz in the RC coupled amplifier. Okay, what is the reason? The first reason is the coupling capacitor capacitive reactance is more in the low frequency ranges. So that is the reason it will fall. Okay. So and in addition to this, the emitter bypass capacitor C cannot shunt the emitter resistor effectively because of its large reactance at low frequencies. Is it clear? So already discussed what is the CE bypass capacitor. If you have not used bypass capacitor, what will happen? Gain will reduce.
Decreases.
The gain
Decreases.
will increase. Already discussed. In the low frequencies, what will happen? The capacitor will not shunt the resistor properly. Is it clear? In the low frequencies, the capacitor CE, the CE means what? Bypass capacitor will not shunt the resistor RE properly. That is the reason what will happen? Voltage gain will reduce. The same thing, same concept. What is the same concept? CE means XC. XC means 1 by CF. F is less. F is less means XC is more. The reactance offered by the CE also more. So that is the reason what will happen? Gain also decreases. So these are the two factors which will reduce the gain of your frequency curve of RC coupled amplifier in the low frequency range. Okay. What are the reason for the gain will fall in the low frequency range for a RC coupled amplifier? Tell me.
Capacitive reactance is more.
So what are the capacitors? What are the capacitors that will affect the
Coupling
frequency
capacitor.
response in the
Emitter
frequency range?
Coupling capacitor,
Very good.
emitter bypass capacitor.
Very good. Emitter capacitor,
capacitor.
bypass capacitor, and CC coupling capacitor.
Coupling capacitor.
These two capacitors are responsible for lowering or decreasing or falling of gain in the low frequency range. Okay. So
Sir.
the low frequency range and the reasons for decreasing the gain in the low frequency range. Next, second case is high frequency range. So greater than 20 kilohertz. So what will happen? So what will happen in the greater than 20 kilohertz? Why the gain will fall? Okay. Below 50 hertz it will fall. Above 20 kilohertz also it will fall. What is the reasons? So above 20 kilohertz, what will happen? At frequencies greater than 20 kilohertz, the reactance of the coupling capacitor very low, and it behaves like a short circuit. Okay. As a result of this, loading effect of the next stage increases, and hence the voltage gain will reduce. Is it clear? The first reason. So what is the reason one? Reason one is that the capacitor which is connected through CC, what will happen? At a high frequencies, capacitive reactance is less. Correct or not? Frequency more, capacitive reactance is less. So it will act like a short circuit. It will act like a simple wire. Simple wire means what? There is no impedance matching. There is no loading. They have high loading effect. So directly you are connecting. There is no connecting element. CC capacitor is not there. It is simple like it is. The capacitor is not there here. If you see the circuit in the high frequencies, what will happen? It is behaves like a simple wire. Simple wire that directly it is connected to second stage. That means the second stage is connected as load to the first stage. So load increases. That means current drawing is decreases. Load capacity is more and more load. Means what will happen? Current drawing capacity will be reduces more and more. So that is the reason voltage gain also fall. Okay. Is it clear? At the very high frequencies, what will happen? It's like a short circuit. That means it is directly connected through this capacitor not there. That means simple wire. It is connected. So what will happen? The directly connection means what? It is load. Load effect is more and more. If you are more load is there, what will happen? Current drawing capacity will be reduces always. So the current drawing capacity will reduce. So overall voltage also reduces, and overall voltage gain also reduces in the higher frequencies. So, and the first effect, this is the first effect. And the second effect, what will happen? The capacitive reactance of the base emitter junction inter-electrode capacitance is low at a high frequency, which increases the base current. This reduces the current amplification factor beta. Is it clear? Due to these two reasons, the voltage gain falls at high frequencies. So what will happen? Another effect, the major effect of this is, so every transistor has its inter-electrode capacitances. What is the meaning of inter-electrode capacitance or inter-junction capacitance or base emitter junction capacitance or whatever the capacitance is called? What will happen is here, the capacitance between the two terminals. The capacitance is between the two terminals. Is it clear, all of you?
Yes, sir.
Yes, sir.
The capacitance between the two electrodes. That means emitter to base or collector to emitter or base to emitter. So CBC, CBE, CCE, they are not affecting the low frequencies. They are come into picture whenever frequencies are increases. Is it clear? Any transistor if you taken, this inter-electrode capacitance will present. Because why? Because it is a three-terminal device. So three-terminal device means three layers are present: emitter, base, capacitor. So what is the meaning? General meaning of capacitor means two electrodes connected, and in between one dielectric is present. Then you can call as a parallel plate capacitor. So something like this here. If you see in the construction of a transistor also, two electrodes like this, collector and base. In between is some dielectric emitter. So what will happen? What will happen? It will act like a one capacitor. And if you collector and emitter, if you see, so it is like a parallel plate. So it is a CCE. So like this also we have some capacitance effect is there. And a base and emitter also one capacitance effect is there. Okay. This will not appear whenever the mid frequency range and whenever in the low frequency range. It will appear and it will come into picture whenever the frequencies are more. Okay. So whenever greater than 20 kilohertz, what will happen? The capacitance effect of this CBE, CBE, CCE, CBC come into picture. Due to that also voltage gain will fall. Is it clear? What will happen? In the higher frequencies, what will happen? Capacitive reactance will be reduces. So what will happen? It will act like a short circuit. So overall gain will fall. Okay. So remember, there are the two reasons. What are the two reasons that the gain fall in the higher frequencies? First reason is coupling capacitors, because the coupling capacitor will at the higher frequencies it will act like a short circuit. Okay. And a second effect is inter-electrode capacitances, or you can call it as a interjunction capacitances. Okay. Due to these two factors also, the frequency response will fall down or gain will be fall down. Okay. So this is the reason. What are the effect is there that will fall the overall voltage gain. Okay. So tell me, what are the reasons the higher frequencies, at higher frequencies the voltage gain will fall?
Capacitive reactance is less, sir.
So what capacitive reactance, what type of capacitors responsible,
Coupling capacitors.
Base emitter.
as well as
Base emitter.
Base emitter bypass
Base
capacitor.
emitter.
junction, or you can simply call as inter-electrode capacitances.
Inter-electrode
Sir,
capacitance.
inter-electrode.
Inter-electrode capacitance are interjunction capacitances.
Junction capacitance.
Why the junction capacitances come into picture? Because of the higher frequencies, it will more. The capacitor effect is more. Frequencies increases, inter-electrode capacitance play a major role. So that will reduce the gain. Okay. It will not appear. Actually, generally they are not appear for a physically. Physically, it will not appear. But whenever your frequencies increases, it will more and more increase. The capacitive effect is more. Physically, you can't connect the capacitors here like this. Like it will not dot. That is the reason they are connected in dotted lines. They are physically not appearing. Okay. But whenever you connect more and more frequency, the signal frequency increases, it will come into picture. Capacitive effect is come into picture. The capacitor means it is nothing but a simple two plates, two electrodes come into nearby, and it will dielectric is there. Okay. So that is the effect of this in the higher frequency range. So mid frequency range, if you see in mid frequency range, what will happen in the 50 Hz to 20 kHz? So what will happen? So between 50 Hz to 20 kHz, the voltage gain of the amplifier is almost constant. The effect of coupling capacitor in this frequency range is such to maintain a uniform voltage gain. In this range of frequencies, when the frequency increases, the reactance of capacitor CC decreases, which tends to increase the gain. But at the same time, at lower capacitive reactance increases, the loading effect of the next stage due to which the gain reduces. These two factors almost cancel each other. Thus, a constant gain is maintained throughout this frequency range. So, voltage and lower voltage and power gain. Okay. So, what will happen in the mid frequency range? So, if your frequency increases, what is the lower frequency range? 50 Hz to 20 kHz. So frequency increases means capacitive reactance will decrease in the first case. Second case, when the frequencies decreases, capacitive reactance will increase. Okay.
Increases.
So Xc increases at the same time Xc decreases. So how it is there means they will almost cancel each other. Is it clear or not? Once the range, for example, if you seen 50 Hz to 10 kilohertz, if you seen, so what will happen? The frequency range is you considered less, means what? Xc is more. For example, 10 kilohertz to 20 kilohertz, what will happen? Frequency is more, Xc is less. So in the first case, Xc is more. In the second case, Xc is less. So like this, it will cancel each other. Is it clear? It will cancel each other so that the voltage gain is maintained constant. Correct or not? So
Yes, sir.
the frequency increases, reactance of capacitor decreases, and if the frequency is decreases, the capacitor will reactance
Capacitive reactance increases.
like this. So it will cancel each other almost it will cancel each other. So that is the reason it will maintain constant voltage gain. So you practically, if you seen, it will not like this flattened curve will not get at the practical laboratory output, but you can make assumption in the theoretically it will have a flat curve. Okay. So I will give you another link. You will participate after 2 minutes of this class. Okay. We will continue in the next
Okay, sir.
session also. I
Okay,
will
sir.
provide you link. Okay. So this is the frequency response of the two-stage RC coupled amplifier. Okay. So what will happen? Tell me once. What is the working condition of this in the mid frequency range? How
When
it is
frequency increases, capacitive reactance decreases, sir. And
next
frequency decreases, capacitive reactance increases.
increases. So overall
They cancel each other.
they will
Therefore,
cancel each other.
it remains constant.
Very good. So almost constant will not, it will equal to constant, but it is almost constant because practically if you see it will not like that flattened curve will not get, it will have some curve which is almost flat. Okay. So that is the reason it will provide the mid frequency range you have to operate the RC coupled amplifier because the gain will constant. That means gain stability will constant. So output is constant. We will get at the output side. If you are not maintained in this range, what will happen? The output will fluctuate. The output will fluctuate means you are not maintaining a constant output. So the load variations is constant, will not get the output. For example, you are this RC stage, two-stage amplifier, you are used as an audio amplifier. Then what will happen? If you are not maintaining constant output at the output side, what will happen? It will fluctuate. That means voice is more or less, zigzag manner, the noisy. Okay. So the output will not, you are not audible easily. It is noisy, effect will be present. So that is the reason this mid frequency range only you have to operate. Okay. Example is audio amplifier. Okay. In the public addressing systems, for example, public meeting, if you see the audio is constant. Why? They are maintaining this range. If you are not maintaining this range, what will happen? The audio will not clear. To fluctuate. Noisy effect will be there. Disturbance, more or more disturbance. So this is the reason this range only you have to operate. Okay. So I will end this here and I will